So hello everyone. I welcome you all to this series of lecture. So today we will be containing the fluid statics. So let's go through what we have done so far in it. Just briefly going over it in fluid statics, and today I will be concluding fluid statics, and will maybe start a bit. Will tell you about fluid dynamics. So in fluid statics, we start with the properties, and we started with the pressure, how the pressure is varying in horizontal as well as vertical direction. Then we have done some questions on it, and we told that the important point is pressure is independent on the shape of the object or the tumbler in which it is stored. Then we have seen what will happen if the vessel in which a fluid is there, how the pressure will vary if there will be some acceleration in vertical direction or in the horizontal direction. Then I have discussed some of the measuring instruments like manometer, barometer, U-tube, and some good questions we have taken there. Then I go through upthrust, the concept of upthrust, Archimedes principle, and law of flotation. And in the same, I have given you one question yesterday. So we need to find out. So this is that question. Uh, whose solution we need to find out, and we need to see what is the elongation in the spring. So I hope you tried this question at home. And now let's see what is the correct way of doing it. So the question is, there is a spring that is massless spring is connected to a block of radius 3 centimeter and height 10 centimeter. So it's sort of a cylindrical block that is here, whose density is 8,000 kg per meter cube. The density of water is 1,000 kg per meter cube. So we need to find out the elongation in a spring. And it was given that this block is floating here in this. So floating, when it is given it's floating, then if you think about it, that about this block, and whose density is 8,000 kg per meter cube, the density of water is 1,000 kg per meter cube. So there were some forces that is balancing the weight of this block. So what are those forces that we have discussed? So one force is the upthrust, that is that is exerted by the liquid to this block, and another is, now there is one extra force, that is by the spring. So spring will try to uh, exert a force on the block towards itself. So the spring will exert a force in this direction. Upthrust also exert a force in this direction, and weight is balanced over there like this. Okay. So let's make a free body diagram of this block. So I told you that to solve any question, first try to analyze it. If you are unable to analyze it, at least make a diagram of that, make a free body diagram, apply all the forces, then you will get a clear picture of it. If you look at this question also, this question. So in this question, if you see, you cannot predict that how one can even solve this question. But it is a very simple question in a way, if you just relate your concepts and try to make a free body diagram. So you have to think over it, try a few things, think about it, make a free body diagram if possible, apply all the forces, and then you have a clearer picture of it, and then you will be able to solve that question easily and correctly also. If you want to go through the shortcut, there may be a possibility that uh, you may lose that question or you may do it incorrectly. Okay. So in this question, I am making a free body diagram of this block. So that is a cylindrical block. This is something like this. Sometimes figures are given like this, you can assume it a box, but it is given that it's a cylindrical box with the radius 3 centimeter. So you have to think about it carefully. So weight is acting in this direction. So Kx, force exerted by the spring on the block, that is in this direction. And upthrust is also acting in this direction. And now it is floating. So now F net is 0. So F net is 0 means U plus Kx minus W is equals to 0. U plus Kx is equals to W. This is weight, this is upthrust, and this is force by spring. So what is the upthrust? So this is completely dissolved in this water. Sorry, dissolved. It is completely immersed in water. Sorry for using that. It is completely immersed in water. So this whole volume, the upthrust is because of this whole volume, because this amount of volume of water gets displaced when it gets immersed in the water. So upthrust is density of water into volume of block, because it is completely floating. It is completely immersed in this. So volume of block into G. What is weight? That is density of solid into volume of block into G. Let's balance out each other, and we need to find what we need to find is X. It came in, I think this is a similar question came in J. Okay, so U is rho F into U into volume of block into G plus Kx is equals to rho S into volume of block into G. So what we need to find out is X. X is nothing but rho S minus rho F into VB into G divided by A. So rho S is 8,000 minus 1,000 into volume of block. Volume of block is pi r square h. Pi radius is 3 centimeter. 3 into 10 to the minus 2 square into h is 10 into 10 to the minus 2 into G 10 divided by K. K is 1,000. That comes out to be 7,000 into 9 into pi into, so 9 I had taken, so that 10 to the power minus 4, 10 to the power minus 6, 10 to the power minus 5, 10 to the minus 4 divided by 1,000. So this becomes 63 pi into 10 to the minus 4, that is extension. So 63 into, well, let's say pi is around 3.14, 190 into 10 to the minus 4 meter. So that comes out to be, if we want to find it centimeter, so that is 1.9 centimeter. Okay. So next question is, so we have two blocks tied to one string. The density of this block is dA. The density of this is dB. Both have same volume, and it is completely immersed in water. This system is completely immersed in water. So this is a massless string. So this system is, it is given that this system is in equilibrium and string has having a tension T, which of these is are correct? A, B is D is dA plus dB is equals to 2dA. D and dB are the density of block A, of block A, and density of block B. So this system is in equilibrium in the water. You need to solve this. So we need to find out if this system is in equilibrium, what are the conditions? So there are more than one correct answer because it is clearly written these are correct. And this is the question of JEE Advanced. So try to solve it. I will be giving you 1 minute and then I will try to solve it in front of you. Okay, students. Okay. So let's look at this question. So as now I will going to solve this question. So as I told you, to solve any question, just make a free body diagram of it. So if there is a tension T in it, so try to make a free body diagram of. So this is in this direction. A thrust is acting. There is a tension T that this tension T is try to pull this mass down. That is T in this direction, and weight of this is also in the same direction. That is mg. Okay. So what is the equation for this is T plus ma into g is equals to ua of thrust, and it is completely inside this. So the system is completely inside this water and at equilibrium, with which is to say that force is 0. So T plus ma into g is equals to ua. So T plus density volume of the block is V for both the blocks. So rho of block A, so dA into volume into G is equals to upthrust is rho density of fluid. So that is dF. This is dF. dF into V into G. So what we get is, so this is the first equation. Another equation is V mb into G, that is T, that is, so T will be in, now don't do this mistake. T will, the direction of T will change. So now T is in the direction of upthrust. Upthrust is also acting in this direction. So now UB plus T is equals to, only one thing is common in both is T tension, is equals to MB into G. So again, this is completely inside the water. So this amount of volume is gets displaced. So that is UB is dB into density into V into G plus T is equals to dB into G into V. Okay. So using this two equation, if you subtract this from this equation, or you can equate T from this two equation, what we get is dF into V into G minus dA into V into G should be equals to, oh sorry, this is not dB, this is dF. This is dB, but this is dF because it's the upthrust. So dB into G into U into V minus dF into V into G. Okay. So from here what we get is 2dF is equals to dA plus dB. So one of the option is correct. Now what about this? So if you say this option, let's divide the complete equation by dg. So T by Vg is plus dA is equals to dF. So from here you can conclude that dF is greater than dA because it is dA plus something. This is something, either it's 0.001. So dF is greater than TA. So dF is greater than dA. So that is correct. If you divide this here, T by Vg plus dA is equals to dV. So now here dV is greater than dA. Okay. So A, C, D are the correct options here. You can also, uh, I I will not going to prefer that option, but by intuition, if you have that kind of intuition and that kind of understanding, you can uh, come up to this A and C options just by intuitions, like C. So A is A. The density of A is try to move up. So the density of A should be such that so it will get float. But B is already inside. Both are inside, but B is trying to pull this system downward. So it means to say that the density of B should be greater than density of fluid. So density of B should be greater than density of fluid. It can only be possibly in equilibrium when one dB has greater density as well as dA has lesser density than the fluid. So they are trying to oppose the upthrust in different direction and then only they are in equilibrium. Okay, let's look at another question. So another question is you have now these the same similar system. So you have this block A, so that is of density rho, another block, another blob of density 3 rho is placed inside a fluid. So I am showing this diagram that is at t is equals to 0. So this is at t is equals to 0. So it is filled with water. So this is t is equals to 0. The density of water is 2 rho. Spring constant is K. Choose the correct option. Option 2 such that this spring mass system must be at equilibrium. Options are elongation of spring is 4 pi r cube rho g by 3k. Elongation of spring should be 8 pi r cube rho g by 3k. Lighter spring is partially submerged. Lighter spring is completely submerged. So choose the correct option and keep it in mind that this is at t is equals to 0. This will take any position to remain in an equilibrium. So I would like you to make a free body diagram and try to choose one of the option among this. Okay. Sorry, this is fair. Spring is anyway submerged. So try to solve this question, let's say in 1 minute. You may pause the video for more than 1 minute and just try to arrive the solution. Okay, so let's think about this question. So in this question, what will happen? So this is denser than the water or the liquid, but this is lighter than the liquid. So what will happen is this will try to go down inside the fluid and this will try to float. And I think after time t, the configuration according to what we are thinking is, and what I'm trying to say is that because this is denser than the fluid, so it will try to push down. So the system will be will become like this, and this will go up. So this will become like this to remain at equilibrium, and this will try to float inside this with the help of upthrust. So again, I told you that what we want is just make a free body diagram. So consider that it is completely submerged. The system is completely submerged for now. So if the system is completely submerged, then these both of these uh, out of this option, D1, let's take this option. So if let's say this option is correct, then make a free body diagram of it. And again, there is a spring force that is acting Kx. So for this block of that is of density rho, so upthrust is in this direction. I will call it as 1 and 2. So upthrust is in this direction. It is stretching in this direction. So the elongation is, so spring try to avoid that. So elongation is in this direction, that is Kx, and weight is this direction, that is mg. So U1, that is upthrust, is equals to Kx plus mg. We are considering that lighter sphere is completely submerged. So if it is completely submerged and density of block is given, it is given. Sorry, I forgot to mention that is V for both the blocks. So V rho 1, because it's upthrust, so volume of block 1, that is V, density of fluid, that is rho into 2 rho, that is 2 rho. This is the density of fluid into G, is equals to Kx plus mass of block is rho into G. Okay. It will create a confusion. Call it 1, call it 2. So, okay, so into V. So we need to find out the extension. So that is rho Vg by K. That is X. We want to check whether what we are doing is correct or not. So try to find out the elongation using the FBT of this sphere also and see if it is coming same. And if it is coming same, then only we can say what we are doing is correct. So now here in this, due to a spring, that is Kx in this direction, up thrust is also in this direction, weight is in opposite direction. So Kx plus U2 is equals to M2G. So Kx is Kx, U2 is the upthrust due to the water displaced due to this sphere. So volume of this, density of fluid, that is 2 rho into G. Mass of this bob is 3 rho into V into G. So what we get is X is equals to rho Vg by K. So elongation from both is coming same. So our initial intuition is correct. So lighter sphere is completely submerged, that is correct. And elongation is X is equals to rho into 4 by 3 pi r cube into G divided by K. So that is this. So A and D are correct. So let me see. So I will be putting 2 questions. Try it at home, and then I will be closing this discussion with the discussion of Pascal's law. Okay. I think I will discuss that question tomorrow only. I will be giving you one question, that is a cube of wood supporting 200 gram of mass just floats in a water. When the mass is removed, the cube rises by 2 centimeters. What is the size of cube? 10 centimeter, 5 centimeter, 3 centimeter, 2 centimeter. So try this question, and I will discuss one more question that is a very important question on torque balance in fluid statics. So I will discuss that tomorrow. So now I will be completing Pascal's law. So before before we start a discussion on Pascal's law, let me tell you, let me revise you what are the forces that are acting on the body. So there are two kind of forces that are surface forces. Another one is body forces. So let me define a surface forces. So surface forces are the forces exerted on the fluid element by its surrounding through direct contact at the surface. And these are of two types. First one is normal, second one is shear. So normal is acting normal to the surface, shear is acting tangential to the surface. That we have discussed in the solid mechanical properties of solid lectures. That is tangential to the surface and that is normal to the surface. Body forces are forces forces exerted on a fluid element by its surrounding through direct contact at the that is distributed over entire mass uniformly. It is usually expressed per unit mass of the element or the medium upon which it is acted. So that's the difference between the body force and the shear force. So, but in Pascal's law, so to derive a Pascal's law, so first I will be going to define what Pascal's law say. So it states that the external pressure, external static pressure applied on a confined volume is distributed or transmitted uniformly throughout the liquid. The liquid in all direction. What it means that, so if you have some body that has having a fluid, let's say the simple way to understand this is, so it was stated by Blaise Pascal in 1653. So let's take a piston system. That is the most easiest way to understand this law. So if you apply pressure at this side, at side A, so there the pressure at this side should be equal. So PA should be equals PB such that F is FA by AA equals to FB by AB. So I will derive Pascal law in next class. So Pascal's law, so I will be going to derive Pascal's law in next class and we'll discuss this question also. Okay, then thank you.